Hi everyone, this is Hiteshi, your host for the day, and I welcome you all to this industry webinar series powered by Comedkares Innovation Center. So, of all the webinar series coming forward, this is the first one where we are going to learn about the prototyping tools and methods. So, we have our speaker for the day, Mr. Rachit Parekh, who is a co-founder at Tilt. So, a warm welcome to you, Rachit.
Thank you. Thank you for the introduction.
Yes, I before we begin, I have a small brief about Rachit and his organization. So, guys, Rachit here is a co-founder at Tilt, where it more revolves around how can there be a sustainable commute within campuses, residential campuses or corporate campuses. So they have come up with the solution that's they come up with the shared bike resources where people, students, or even corporate employees can actually move from one place to another within campuses in a very sustainable and an eco-friendly way. So, and the best part is the company here is backed by Y Combinator. And for those who do not know Y Combinator, it's one of the leading technology accelerator in the world. So it's one of the finest accelerator. And Rakshit here, his company is from Y Combinator. So, Rachit, it's a pleasure for us to have you with us here today. So over to you, Rachit.
Great, great. Thank you so much for the lovely introduction. Yeah, so is my screen visible to all of you? You can just put a thumbs up and say, yeah, great. So I'll quickly introduce what Tilt is, what we are doing, and then we'll dig into the prototyping methods. So first of all, little background of Tilt. So we started this company almost 3.5, 4 years back, and we were right in colleges as you guys are right now. We were in for third year college where we began this journey, and we started with a problem. So yeah, so this is the agenda for the day. We'll start with something about Tilt. What is the product? Early prototypes and pilots, and our journey from how we went into prototyping and how we are now a full-fledged product, and how many and like millions of users right now use our bicycles daily. So, and then we'll move into a Q&A session. So quickly on Tilt first. So as I mentioned earlier that we started Tilt in college, and now we have reached almost 100 plus apartments across Bangalore, Pune, and Thane, and we have 1 lakh plus users using our bicycles, 4 lakh plus rides. The impact that we have created using our bicycles and our goal to shift mobility towards a sustainable mobility is the impact that you can see right now. And we are goal is to just keep it increasing and reaching to more and more apartments within these three cities. So first, what we do. So by shared bicycle, I think what you guys might think is like a bicycle that I share with me and my friend, and it comes to be a shared bicycle. And this is exactly how our journey also started when we began. So this is a photo of how our station currently looks like, and it's a bicycle that is shared by all 1,000 plus apartments within this residential campus. And just with a tap of a button, you use a mobile app, you scan the QR code, unlock the bicycle, and then you lock it back once your trip ends. So this is a product. This is a amalgamation of all the 4 years of work that we have put into building this technology from scratch. So by scratch, I mean literally we were the ones who initially started like doing laser cutting, cutting metals, welding. So this is how the journey began in our college days. So when I talk about the problem, right? So you are college students, first years, just entered into college, and you'll face this problem soon if you are in a big college campus. So how do we commute inside this college campus, moving between department to department, canteen to hostel, hostel to canteen? So we had two, three options at that time during our days. Either we had to walk, and this was in Chennai, so you can imagine the heat over there at that time. And it was very tiring. Shuttle buses almost crowded most of the times. Rickshaws like haggling to and fro too much times, not very accessible. And cabs are like out of our budget during our college days. We wanted a solution to our own problem during college days. And what happened is I and a friend of mine bought a bicycle together because we were short on funds and we wanted to like share a bicycle among ourselves. And that got us into the idea that if me and my friend can share a bicycle, why not the entire college campus use a shared pool of bicycles, right? No one has to own a bicycle in the college. No one has to think of selling the bicycle when they move out of the college. So many problems solved, and then like we can easily go from department to department anytime when we want. So we took this problem statement and then began our journey to experiment like what we can do to solve campus mobility within this college campus. So the first step, I think, for us was to ideate, was to get feedback. We just had this one line problem statement in hand, and we wanted to see if this actually makes sense. Is it the problem that only we are facing or the entire college community is facing, right? Is it like possible that we can work with administration? They have some feedbacks for us. So we tried collecting user inputs. We tried conducting interviews of what sort of a solution do you look for? What sort of an app UI you want? How do you want to unlock the bicycle using an app, using a RFID card? And we wanted to see what type of bicycles a college campus does require. Is it like a female bicycle, step through frame, or MTV bicycle? So we started experimenting and getting user feedbacks from the ground, and then we came up with a experiment, a problem statement, and a thesis that yes, they require bicycles. They wanted to be a shared pool of bicycles, easily accessible, just using a QR code or a tap of a RFID card. They should be able to unlock the bicycle, move around the campus, and lock it back easily. So then this was our first start. So, in contrary to the image that you must have seen in the first or second slide, there is a beautiful bicycle docking station. It's began all over here. So we started building a. It doesn't look like a bicycle lock. It looks more like a cupboard where you can put the bicycle. Right? It's so big and clunky. So, but yeah, everything starts with a small version of a prototype, right? So this was a prototype that we created in our college, in our workshop, to see, just to imagine, like put our ideas that were on the paper in the real life. So now fabricating this, we had like tools available handy in the workshop, getting metal sheets, getting a laser cutting machine, getting the cutouts done, and then welding it together and making a structure in place. So this was a very basic rudimentary version of a prototype on what we wanted this to look like. Then, so we again went into nitty-gritties of what the technology should consist of, right? So imagine like in your heads, you want a bicycle to lock and unlock using a electronic ID card. So what comes to your mind? Like there has to be a locking mechanism that uh, physically locks the bicycle, right? No one should be able to take out the bicycle. So we started with that aspect. So there has to be a physical lock. You know that small horseshoe locks that come, right? So we started with that version first, and then we quickly moved on to the next version of what is it that requires that is needed to lock the bicycle, right? So you can see a version over here. So we what we thought is, why don't we split the entire bicycle locking and locking idea into various sub prototypes. I think for any project that you guys take up right now in your internship or in college, I think this is a standard rule on how to begin it. Break it into small sub mechanisms or sub prototypes for you to work on, and then go ahead and then integrate into one single prototype. So we started with, say, structure. That is one part. A locking mechanism for the bicycle. That is the second part. Uh, a mechanism to detect when a bicycle enters, right? So, for example, I don't know when I lock my bicycle if this is the correct bicycle that is locked inside or not. I had a rest of a unique way to identify which bicycle has come in. So we started with a sensor over here. You can see a small ultrasonic sensor that we plugged in. And then we need a RFID scanner, similar to how, I don't know, if in your office you have an ID card that you use to punch in the attendance, right? Similar to that, a scanner we used to lock and unlock the bicycle. And this is how we split the entire prototyping journey into three parts. Now the next part was how to integrate this into a single full-fledged product, right? And for that there are like say various hardware prototyping as well as electronics prototyping tools that you guys can use once you create like your first prototype. I'll come into software prototyping later, but just focusing on the hardware part right now. For design aspects, I think once you have an idea in mind, you want to have something digitally first before you go into like building something on the physical world. So there are like tools like SolidWorks, Fusion 360, OnShape. Sometimes you want to have a ready-made CAD model directly from the internet, so you can use GrabCAD for that. You can say, suppose I want to get a bicycle model for me to test it out. How does it like look like, right? So I can directly, I don't have to create the entire bicycle from scratch. I can go to the website, download the bicycle, and then I can like start working on my solid modeling. So once you have the digital picture of what you want to have in place, then the next step is to go into metal fabrication. So metal fabrication, like the standard tools that you use, right? The basic workshop tools, lathe, welding, bending machines, laser cutting, CNC machining, right? So I don't know if you have been introduced to these tools, but you will soon be introduced to this basic tools that will help you to build physical products. So this is around the metal part. For plastic fabrication, you can use 3D printing is like the very go-to tool for any prototyping that you want to do. 3D printing, then urethane casting is also a low volume prototyping technique that is used generally for in the industry for making rapid prototypes, right? And then so suppose you don't have a 3D printing with you or a urethane casting facility, right? There are like tools available on the internet, right? So there are like various cloud manufacturing services where you can just once you create a cloud CAD model, right? You can just upload your file in the CAD in the software that they have, and then they can directly ship you a 3D printing or urethane casting piece to your place. So various services are built around that. So this was one of the things that we used to accelerate our prototyping journey. And I'm sure, like, I think it might be quite useful for you all. The next part is towards electronics prototyping, right? Again, a standard set of tools, same process. Get it first digitally in hand. Design softwares like Eagle, Altium. You'll come across much more in your course. And same with PCB fabrication. So once you have a design in place, you have to build that PCB physically, right? There are many PCB fabrication services available. So in Bangalore, in Gujarat, we did our PCB fabrication first few samples in Gujarat. So there's a company called PCB Power. Again, same process. You upload your file, PCB file into the cloud platform, get the prototypes made within like 1 to 7 days, and then you can start working quickly on the product. And apart from the basic hardware and the electronics prototyping, you need many additional components and additional hardware parts to test your things out. Maybe it is fasteners, maybe it is small electronic components, sensors. So all this is like your go-to places. There. Just search for what sensors you need. You'll be able to get tons of websites that sell the sensors. So your first step after you like have an idea, build a design, a digital design in place, go for fabrication. There are like fabrication services available online or offline. You can like go to some workshops, get your hands dirty, build your first version of prototype, and then for any other additional hardware that you require, you can like get online and just try quickly to get something on hand that you can physically touch and get working on. So this is the process that we followed. And you can see once we had a prototype in place, our immediate next step was to bring it out to the public as soon as possible, because no one else can give a better feedback than the users itself who are the consumers of the product. So, and we wanted a different segment of users to give us feedback, right? We wanted to test our market also. What type of market is best suitable for such a solution, and what is the what inputs do the consumers of that market have? So, for example, we started in SRM Chennai, not very far from Bangalore where you are. So we started our first pilot over there where we developed this bicycle sharing system for the students. And like students, once you are college, you always have this nefarious nature of trying to fidget things around and try to mess things up. So it was a problem for us too. So the day we deployed in SRM with three bicycles, all the three bicycles were lost this first single day. Like students just took the bicycle, they hacked the mechanism that we had built, and then it was like gone. So we knew that our mechanism was not robust. Something that was tested in the lab was not working in the real life because people were just figuring it out how it works. So then it gave us feedback on what to build next to make it more robust. The next pilot we ran is in golf grounds in Nasik. So it's a park where direct like people who go for walking and jogging wanted to use bicycles for fitness. So over there again, it's a humid environment. It was out in the open, and we wanted something that is very modular, right? We were fabricating, we were manufacturing in Chennai, and we wanted something to transport to Nasik. So the first version of the system you must have seen those big clunky metal structures that we had. It was very difficult to transport. It was very costly to transport. So we thought of an idea of like, why not just build a smaller version of this and make it replaceable, right? Get a metal beam, put the docks in place, the locks in place, and why not make it a plug and place its type system, right? This was the next iteration that we made on the design. And then this is the third campus that we piloted was in Tata Motors in Pune. This is again a big campus with the customers here being the employees of the Tata Motors plant, and they wanted to use these bicycles again for commuting between the departments for work. So over here, interestingly, they didn't want a QR code, a mobile phone type feature because mobile phones are not allowed in Tata Motors, right? It's a it's a confidential information, right? If someone just clicks a photo within the plant, so they just banned mobile phones, and now we had to figure out a way for them to unlock the bicycle using their own ID card that they used to punch in the attendance. So then we incorporated that feature into our system, and then we had one more version of our docking station where the employees can easily, with a tap of ID card, lock and unlock the bicycles. So running quick pilots, what helped us really to validate what we were working on the lab was actually true or not, right? We got a lot of user feedback on how to run these pilots and how to what users actually need. So it was so getting this data was is crucial. And for you, once say you start building things out, it's very important for you to get the product to in the hands of users as soon as possible. So yeah, that is the next step in the process. So you go build your first few handy prototypes, test it out, and then directly go and get it to the hands of users, get the feedback again, and iterate on the product. So repeat these loops once, twice, thrice, and you will not believe your product will be matured at a very significantly quick time, right? So now the next phase for us was going from a prototype to a product. So in the first slide, you must have seen we have 100 plus campuses. That means hundreds of those individual stations have gone and have been produced repeatedly to do the same function, that is locking and unlocking the bicycle. It may sound easy, but actually it's extremely challenging to repeat that same product again and again in the ensure that the same quality of product has been built. So and then there is various criteria to look into while you build a product and you go from a prototype stage to a product stage. So you have to incorporate cost. So how costly the product will be, right? For the prototype sake, maybe you put a lot of money just to make the things function, to make the things working. But at scale, you have to incorporate this fact that what is the cost that I'm buying the product for? What is the cost that I'm incurring to build this product out? Then the next point is design for manufacturing. So what a design that may work for the prototype stage might not work for the manufacturing stage, because in manufacturing there are different sets of machines, different sets of tolerances that you have to take care, right? There is assembly of this docking stations that has to be done. This has to be done repeatedly. So for that, to build to replicate the same design, the design has to be built in such a way that it is replicable. So there you have to do design tweaks. You have to see what machines the manufacturer has, tweak your designs accordingly, and then go into the next stage. The third aspect is testing, like test. This is like the single rule for making like things work perfectly. You have to test the hell out of whatever you build, get it into hands of users, and for product stage, it is much more difficult because any small issue that you have in your product is multiplied 100 times for that same user. So imagine the problem that a bicycle is not locking, say, for one campus or one prototype, and then in 200, so 100 bicycles 100 times not locking or having some issue, right? It just exponentially intensifies the problem. A small bug in the software or small change in the hardware that you have to do. And so for that, like, test very extensively before you go into replicating the same product again. And then production, right? So I'll not go much deeper into production because that involves a lot of things in terms of getting the processes right, getting the inventory right, when to get the inventory, how much to store, how much to build, how much to ship. So it's again a challenge in itself. I wanted to mention this point because you have a idea of the bigger picture of what a prototype looks like and what it requires to go into the product stage. I'm sure many of you in future might like work in industry or start your own hardware focused companies, and you should have an idea of the difference between a prototype and a product, and how what factors are involved in that journey. So yeah, we took these 4 or 5 factors and then re-engineered our design. So from those big clunky dogs, we made something that looks a little bit more beautiful and more appealing. So this is the render. Like, if you guys want to know how we created this render, it is a software called Keyshot, Keyshot. So once you create a solid model, maybe on any of the solid CAD software, this is a software that beautifies the product. Like, you can add touch, feel, texture to the product itself to see how it will look in real life without actually making the product first. So we re-engineered our product, made it look beautiful, and then see and then went out again to see how to manufacture this design. So in that process of manufacturing the design, again, a lot of changes happened, right? So the changes from prototype to product to manufacturing at scale. And over there also, in the second step also, there are a lot of iterations that you have to keep on doing to get the product working. In the first stage, the feedback comes from the users, but in the second stage, the feedback comes from the manufacturers. And because you have to closely work with the manufacturer to see what is possible and what is manufacturable and what is not. So to give you an example, if you can see the bicycle on the top left, there is a small sensor that is used to detect the bicycle, like what is the unique code of that bicycle that we embedded inside. So, so this bicycle code, we had just stuck it using a rudimentary glue sort of an adhesive, and then we thought that it will never come out because it was not coming out in lab. But then once you put it out in the system, in the public, then I we were just observing that after 4 to 5 trips, once users take on this bicycle, the glue was peeling off because of sunlight, because of rain. Again, that issue was happening. So we then looked back into the industry to see what solutions we can make to do this permanent setup of the tag inside the bicycle. So so this is the example of a feedback that comes from the manufacturer's end, and then we incorporated that to build our system. Same thing with the docking part, right? So in the top right, you can see a 3D printed model, right? That is used to house our PCB and all the electronics that we have made. And in the middle figure that you can see a sticker sort of thing kept. So the middle part that we had built using a acrylic plate, right? We cut an acrylic plate, bent the acrylic plate, and then stuck it with the glue, and then put a sticker on top of it, and then shipped it out to the campus. And then we observed that again, because of outside environment, sunshine, and rains, the sticker kept peeling off. The glue was not bonding so nicely, and then we wanted to have this a repeatable process in which we can manufacture tens and thousands of this without having any issue. So we quickly went back to the drawing board, made a small prototype, and first thought of the manufacturing process that we want to use, right? So now we wanted a manufacturing process that can have a product that can repeat till 10,000 units and then not cause an issue. So there is a process called injection molding. Every plastic part that you see nearby, like from your mobile cover to your water bottle, a plastic water bottle. It's made using a process called injection molding. And for injection molding to be made, you have to first make a version of a product in, say, 3D printing or urethane casting before moving into the bulk manufacturing process. So this is a process that we followed. We made a 3D printing part, had an acrylic plate on top of it so that the sticker is permanent, and then quickly moved into the injection molding, where we have to test, where we have to see if the specifications that we were there when we did the 3D printing part are the same as when we are developing the injection mold for it. And once it was tested, trial was completed, then we quickly moved on to manufacturing it in bulk. So like the points that you have to note in this is in the second stages, get the manufacturing process, idea of manufacturing process first before going into design, right? So these are the few cases where that might be useful once you are in the second stage. And the next part, once you are at a product stage, from prototype stage, I think is making a case, a thesis for the product, to mention how long you want the product to be sustained in the open environment, right? So for us, the example, we want an intuitive user interface. We want a robust locking mechanism. We want the product to be waterproof, dustproof, 5+ years of life. We want it to be modular. We want it to be low maintenance, right? So once we run the system, it should not give us much maintenance. It should be easy to install in these campuses. So these are the factors so that you have to consider once you have the physical, like basic functional product in place, and then you are optimizing your cost and your setup time. So so this is like the hardware part that we have. And like for you, if you like create a really unique use case for a product, I think what you can do is you can patent your design as well, because this is the dock. Since we have worked for 3 4 years, we patented the idea and the design behind this dock, so that we have some commercial value that can be utilized for years and years, right? So if you guys like go and planning to build something really great, make sure that you think of patenting it as well. Now, I'll dig in deeper into the software part. So to enable this locking, unlocking, It requires a robust, complex piece of software to manage the entire gymnastics of this process. So we have an admin panel. So this admin panel helps us to see each bicycle, where it is, which station it is locked in, what is the usage of the bicycles, how many hours it is used, how many people have ridden on the bicycles, where is it locked, if it is not locked, is the dock in an error state or some issue is there with the dock. Everything is there in a single source of truth for us over here. We have a user facing app for the users to lock and unlock the bicycle using the mobile phone. And then we have an operator facing app. So these bicycles need to be maintained on a daily basis, right? So for us, suppose say you ride a bicycle, a pedal broke down, you are a customer and you put a ticket on the app, right? Say this bicycle, I took a ride, but the pedal broke down. Now I want this pedal broke down ticket to be reflected for my mechanic to him to solve, right? When he goes to that campus. So then for that, we created a operator app for mechanics to see what problems are there with this bicycle and then solve it. And and how to build this apps and software without using a single piece of code. Right now, you might be going into different streams, maybe computers, maybe mechanical, but like this is there are tools available out in the internet that you can build a simple software, say for example, an operator app without writing a single piece of code. So here I'll come to software prototyping. So this two screens that we have built in our app is completely made without writing a single piece of code over here. So there are tools like Airtable. So you can use Airtable to put all the, it's used as a database for you, like similar to how you use Excel sheets if you have tried it in school. Similarly, this is an Airtable where you can use it to build, say for example, I want to, you can see over here in the screen, there is something written over here as 30 rupees cashback, right? So this 30 rupees cashback, if I want to reflect it on the screen, it has to come from some place, right? To appear that over here. This some place is a table that you can use. So it's a database for storing all your data. And you can use Webflow. So building beautiful marketing websites. There is a beautiful software called Webflow. Without writing a code, it's again uh, drag and drop sort of a feature where you can build nice websites, marketing websites on this. And then software is a tool that we also found out fairly recently. So this is a tool that helps you build like great apps, great dashboards. So the admin panel that you saw can entirely be built on a app called software. So you can use these tools to just get on to the first prototyping part of the software. After all, eventually you have to write code. There is no way out of it. But to test it out, if something is functioning or not, I think this is a good way to start. Uh, so yeah, I think we covered hardware prototyping, we covered software prototyping, we covered how to prototype, what to how to start with. We covered about stage from prototype to product, what factors to consider over there, and then I think what you guys should keep in mind is you have to run parallel experiments together, right? So it should not be that I'm building something right now. After this happens, I'll go on to building the next thing. You have to run two, three experiments in parallel so that if at all one fails, you have other three or two in backup. What this helps is in improving the speed. Right, the biggest challenge in hardware development is speed. How fast you can develop something, and running parallel experiments is the answer to that. So yeah, keep running two or three parallel experiments for the same product so that the chances of making something work are higher. Then next is talk to your users frequently, right? To get your feedback from them on the product, on the business itself, and see how what are the feedbacks and how you can incorporate into a product and solve the problem. And test extensively, test, and test with the user, test in the lab, test out in the environment, all sorts of testing. Just keep in mind that you have to test before you scale. And the last bit of learning is, I think maybe it might not be that relevant for you at this stage, but make sure you keep in mind in future that production is something much more challenging than prototyping, right? So if you have this idea when you start prototyping, right, it's good, right? It's better to have this big picture of how things are made at scale, so that you have a big picture and you factor that subconsciously when you are building that prototypes as well. So yeah, with that, I think I'll end, and any questions, happy to answer.
Yes, thank you so much, Rachit, for that detailed explanation of how your idea came to a prototype stage, and then it became a full-fledged product, and then manufacturing, and now how it's all across. So
Yeah.
thank you so much for such a detailed explanation. Meanwhile, students, the chat is open. Please feel free to drop some of your questions here in the chat box. For the next 10 minutes, we'll focus on Q&A. Meanwhile, two quick highlights which I picked from. There are a lot of pointers that you gave. What I considering the relevance for the students right now, at least from the place where they are, because the students right now have finished their first year, and then they are now
Yeah.
moving to their second year. So for them, because they are into this internship where they are building prototypes, after building prototype, it does not end there. Testing, that's where you can validate your prototype. And even when we say testing, it's not just inside a very controlled environment. It's always necessary to go out, test, and at the same time to also get feedback from the user as much as possible, because that's when you know the prototype that you've built is something that's actually what somebody wants to use it or not. That's a very
Yeah.
critical advice. That's one thing. And second is you mentioned about how you built applications where it was not even coded. So for all those people who feel feared that I do not know coding, I'm from a bio background. That's like a norm that we hear, trend that we hear in most of the bio students, or irrespective of somebody saying I'm from mechanical, I don't need to know coding. So there are a lot of tools that's actually available, irrespective of which branch you are from. There is always space for you to experiment with those subjects which you may not are from, but you can still experiment. So these are a couple of quick pointers I wanted to highlight it to the students. So guys,
Yeah. Wonderful.
the chat is open. Whereas I would like to ask you a first question as an opening question, asking saying most of our students right now are in the research phase, as in they have been introduced to a problem statement and now they are doing research around the problem statement that they have gotten. And based on that, they'll slowly start after talk. They'll also be going to the fields, talking to these people who are facing the problem statement, and they'll be coming back. After which they start with their ideation. So when they sit for an ideation, there is a tendency that you want all the premium features that you have in out there to be in your product. And you clearly do not know how much of the feedback given by the user is something that I need to take in. Some of them that I need to keep it parked. There is no that first level of screening happening. I listen to everything, and then there is all the best features I wanted in my product that I'm building. How can I avoid that and know how much do I consider at least when I'm prototyping, and how much of it can keep it in the future stage?
Right. I think this is a very good question. What we have to do is, like, in the addition phases, make a hierarchy, right? Hierarchy of features, and rate it, score it with in terms of how important it is, maybe in scale of 1 to 5 or 1 to 10, right? And then see how much time you want to get into the prototyping phase, how quickly you want to get, right? So these are the two levels that you have to play around with. And once you prioritize in terms of how much time it will take for the product to be for the prototype to be built, and how important is that feature, and you quantify both those aspects, I think you have a good judgment of what products and what features you want to pick first, right? So say for example, we are building a operator app for our mechanics, right? Our, we had a lot of features to be built. We want the operator app to see all the tasks for that day. We wanted him to mark his attendance remotely when he goes to a location, right? So millions of features that we had in our mind. But what is the basic minimum feature for building an MVP that is needed, and you can test it out? So for us, the main priority was to make sure that he gets the ticket that a user generates. All other things are fine, right? We also wanted to preventive maintenance on the bicycle, but that you can park it on for later. So we took that one single feature that we wanted to build, and then build it out quickly, tested it out, and see if it is working or not. So I think if you can prioritize your ideation process and put it under two buckets, that is time and that is difficulty, and then score it. So and then you can find a right balance of what features you want to pass it through that funnel of time and difficulty, and what you do not want at this stage.
Okay, great. I think that gives great input in terms of how they should actually consider features when they are actually building. So I think I got a message from Shrajan saying the students would like to unmute and ask questions. So yeah, over to you, Shrajan. You can unmute and ask your questions.
Hello, good afternoon, sir.
Hi, Sajan.
That's not Shrajan. That's a student.
Oh, that's a student. Okay. What is your name? You can start with your name
My
first.
name is Ambush Kumar Sharma. I
Okay.
is on college. Yeah. Sir, my first question is why you choose in private place?
Can you repeat? I'm not able to get your question. Why you choose?
Why you choose a private place like university and Tata, Pune and Golds Club?
Okay.
Why you
Understood. Understood.
public place?
Yeah, so at that time we have seen, right, what a bicycle, if it is out in the open in the city streets, what sort of behavior normal residents, normal citizens used to do. They used to just pick up the bicycle and go. There was no control, right? Even like there's no security inside, outside in the open cities. It's very unsafe for an asset, for an investment that we had made. So it was purely based on like our common sense and our budgetary requirement that we don't want to lose the bicycle, and the best way to not to lose a bicycle is putting it in a closed campus. So that was our thought process at that time.
Hello. Sir, my
Yeah.
main question is uh, what is different between a prototype and pilot?
What is
Prototyping
this?
and prototyping and piloting.
Yeah.
A difference between prototyping and piloting? Okay, prototyping is a thing that you just do it in a lab to make a physical product and make it work. Pilot is a much bigger thing, right? Pilot in terms of you have to design a pilot where multiple stakeholders are involved. In prototyping, it is just you and the product itself. A pilot means there is like administration involved. You have to speak with the users. You have to put the system in place over there. So there are like various angles to a pilot, right? If you want to design a pilot, there are multiple parties involved. There's like, so for example, in golf club rounds, when we wanted to pilot with four bicycles, we had to speak with, say, the municipal corporation over there of how the pilot will look like, what sort of timings we will have in that pilot, like when can the bicycles be accessible. So it's a much comprehensive much comprehensive way to implement a system in a smaller scale. I think that I can define as a pilot, where you actually are giving the product to the users, but in a very small scale.
Sir, my third question is can we log only this bicycle or another bicycle? Any other?
Yeah, a very good question based on images. But yeah, so what we had done initially was we had an attachment on the bicycle that you can add it for making it part of the shared fleet, where any bicycle can be used to lock and unlock after attaching that part. But now I think it is just the bicycle that we manufacture ourselves, right? So we have a physical part that is welded into the bicycle because we don't want any other bicycle to be locked into the system. We only want our bicycles to be used. So it's a permanent solution, and no other bicycle can be locked. Only the bicycles that we design and we weld the parts to can be locked into the system.
Okay. So,
Yeah.
Rachit, would you like to take another question because we are almost up with the time?
I can take one more question if anyone has.
Okay. Guys, do you have one more question?
Uh, yeah, sir. Hello.
Yeah.
Yeah, I'm Srajan. So I had one quick question. After prototyping, when we are going for injection molding, for when we are going for mass production, so what would you suggest is the best number for injection molding? Since the molding cost is more, well compared to 3D printing or other prototyping processes. So when do you think is injection molding better, or what scale when you're producing the product is better to go for injection molding?
Yeah. So for injection molding, I think anywhere if you are looking for more than 10,000 parts, then only the cost of the mold is usually justified for injection molding, because almost a mold cost upwards of say many lakh rupees, a dozen lakhs, and for you to break even on the cost of that mold, you have to produce that many parts, right? So I think between 10,000 to 1 lakh, I think that is the best range for going to an injection molding. Anything below that, I think either you can go for a new process has come up called urethane casting or vacuum casting, where you can, if you have product quantities between 500 to 1,000, and you still want the finish of an injection mold, you can use that process. And anything below that is 3D printing, or you can use acrylic if the design is not very complex.
Oh, thank you so much, sir.
Thank you.
So, with that, we come to the end of first webinar. So, thank you so much, Rachit, for
Thanks a lot.
for this great session. And before we conclude, I want to know from you if you have any concluding remarks to all our budding entrepreneurs sitting in this room.
I am not that wise of a person to give remarks, but I think what lesson I've learned in last 3 4 years is don't shy away from exploring new areas and new possibilities apart from your field, right? So if you are a mechanical engineer or an electronics or electrical or a computer, I think going into that same set path might lead you to the same set things that other people have followed that path on. So don't shy away with exploring new possibilities within the college, within the streams. I think some or the other way, I think something might click for you, and I think you might end up into something great product venture or great idea, I think. So yeah, don't shy away from exploring. That is the one uh,
Yes,
advice, not much, but a lesson that I would like to do.
yes, well said. Thank you so much, Rachit, and thank you so much, students, for being sport. And with that, we end our first session for the day. Thank you all.
Thank you, Tashi. Bye.
Yes, you too.